Okay, go for it.
Okay, I'm gonna have to join the meeting to share. Give me 1 second.
Yep, go for it.
Can you guys see?
Yeah, you gotta mute yourself on one of them.
All right. Okay, so let me start. So I did send out the pre-read. So I'm trying to try and summarize this more succinctly rather than walking through the doc. So the problem. So what's the problem? Let's start with that. So say I want to write ARM kernel, maybe let's say for a 3-bit lookup table based quantized linear. Now I want to say I want to leverage this kernel on Edge, PyTorch eager, compile and Executorch, right? So this I want to have this kernel return that can be shared across 2 different runtimes. Eager, compile, and 3 different in that sense. So establishing there is a problem. The question is, why is that hard? Like, why can we not just have that kernel return and being used by all of this in all these different runtimes? So there are mainly 2 issues. One is that ATen, Executorch and PyTorch have different tensor definitions, which is what we use for kernel to interface with a runtime, which is what I was highlighting here, that kernel tensor interface. Second is the operator registration mechanism, that the both runtimes have different ways of registering operators as they are maintaining 2 different two different registries, right? And they also have different dispatch mechanisms. Then they also have their own like a smaller issue here is, right, they have their own interfaces for thread pool and if you want to leverage thread pool for multi-threading for these kernels, they have different interfaces, right? Execute has its own, PyTorch has its own ATen parallel for implementation. And if you solve all these above, then there's a question of like, how do we actually go about packaging and distributing these kernels so that it can be leveraged by model authors to quantize and then leverage these kernels for the quantized models. Right. So given that, the solution space that we considered, which I'll get to. All right. So solution space we consider were mainly 3. That what if we don't do anything? Just copy paste, right? So there's a kernel there. We write the kernel somewhere that is used for PyTorch. We copy paste that kernel for Executorch somewhere in Executorch repo or some separate repo. Wrap that up in a Executorch specific repo, register to Executorch registry, and boom, you have the kernel available for Executorch, separate code for PyTorch. Second option is that okay, we can share the kernel, but just have a separate registration mechanism. So we can write 2 separate wrappers, which internally will just talk with the runtime with the Executorch tensor or ATen tensor, depending on PyTorch's Executorch, and then just call the underlying kernel. They will all both of them will have their own build artifacts with CMake and things like that, and that will be used to actually ship the kernel. So you're still getting the kernel shared, but have to do some boilerplate code for registering the kernel to 2 different runtimes and take care of going from Executorch tensors to the kernel interface and PyTorch tensor, ATen tensor to kernel interface. Right. Okay, so that's like super quick overview of what the problem and solution space considered here is. So I'll stop here first and then see like if any questions further on this.
Questions from the room? I have a lot of questions, actually.
Sure.
Okay, let's. I want to establish some background stuff. Okay, so let's talk about Executorch for a little bit. Okay, some of this people might already know, but I just want to get it out there. So first, what hardware does Executorch target?
So it targets so within the like so there's a mobile and there is a internal AR/VR devices. Within that we have different SoCs that have CPUs, GPUs. This include Android GPUs, iOS GPUs. Then there is accelerators like neural engine from
Actually,
on Apple.
let me make this question a little more pointed, which is for operators you want to share, what what architectures are you targeting?
CPU and Metal, like MPS.
Okay, can we ignore CPU? Sorry, Metal, for the purpose of this
Yeah,
conversation?
I think for the purpose of this discussion, let's just focus on CPU only.
Okay. So tell me about the build system for Executorch. So I know you guys have a requirement on C++ version. Tell me about CPU architectures you target. Tell me about your packaging for CPU.
So we recently upgraded to C++ 17. That's right, Mongol? That's my understanding. Okay. So in terms of CPU being targeted, it would be both ARM v7 and ARM 64. I think internally I'm not sure if we have any deployment on v7, so this will be mostly 64-bit ARM architectures. Yeah, that's
how does binary packaging work for Executorch?
So today, I think most of the places we will actually deploy for the runtime itself, it's mostly, as far as I know, it's built from source and then we package into the target application or the binary. So it's not a pre-built artifact which are shipped, well, we do have like Android specific R files and iOS specific Swift packages also. They're available through S3. So there are some workflows in which you can just download this pre-built artifact and integrate in a part of your app.
But those binaries are actually irrelevant for the CPU kernel sharing problem. Is that right?
Yes.
Okay, and then also tell me about your runtime file size requirement. So how big is the Executorch runtime, separate from the kernels, and what is your target size in terms of binary size?
Target size specific to this, or
for
what
CPU,
we're discussing here?
For CPU, for the stuff we're sharing.
I mean the code itself is like 50 to 100 KB as far as I know. Yeah.
50 KB.
Yeah.
It's currently 40 and we have a limit of 50.
Okay.
Do you know what the size of ATen is, by the way, off the top of your head?
It's harder to get a minimal because it's not as fully separate. So it's not totally apples to apples, but I think our smallest was 800 or something on Messenger.
Yeah, I remember it was close to that. Yeah.
Okay. More questions. Tell me more about ET's thread pool. What exactly is the thread pool implementation in ET?
So that's really underneath it is a p-thread pool implementation and provides a equivalent interface to it, equivalent of Parallel 4. So you just right now just backed by p-thread pool.
Yeah, but in PyTorch typically we use OpenMP for the underlying implementation.
Yeah,
Parallel 4.
Not anything.
OpenMP does not work on iOS, so it's kind of a non-starter.
So just to understand correctly, all your CPU kernels are single-threaded?
No. They are multi-threaded using p-thread pool implementation, not OpenMP.
So you're using p-thread.
It has to be. Yeah. So yeah, you have to invoke manually Parallel 4 invocations. There are no OMP Parallel 4 in the code base.
Okay, some more questions about the running. Tell me about memory allocation. How does memory allocation work in Executorch?
So right now all the operators in ET are out variant. So for that allocation happens, well, you get memory plan. So you get an arena that you plan, and then all the out tensors of the operators are offset into this arena. But the allocation of the arena itself is the problem for the integration surface. So they have to query the arena size and allocate the arena size and pass that into the initialization of the model itself, and then it will just offset into this arena for different tensors, and those are the different out tensors for the operators.
So is dynamic allocation supported at all in Executorch or no? Basically, do you have malloc?
We sort of. It's not fully set up, but we have like skeleton code there. You would pass in an allocator at like initialization, and then that allocator is exposed through like an extra argument into all of our kernels, and then that would be used under the hood to kind of resize, and then we have a free instruction that would get injected. So you could do fully dynamic that way. But baseline would support a non-malloc system. This is and this is a similar process to how you would get scratch space within a kernel, like if you needed more than order 1 space.
Yeah, but that
different allocator.
But that's only if you wanted to be compliant. I mean, there is no restriction on the custom operators or like delegates. They can do whatever. They can do like start vector or malloc within that. As long as they manage their memory, it's fine.
Yeah, that's also true.
No, I don't understand. So are you saying that you allow kernels to arbitrarily interact with libc? Like you don't have a like CPU allocator that is being forced to be used?
Right.
I guess the core lib, though. No, the core lib you do have to. For like any tensor type stuff, like the portable lib has to go through this. It can't just arbitrarily call malloc. But if you were writing a custom op or like an optimized kernel, then you can do whatever under the hood. But you still can't kind of like trash the tensor's data pointer. Like the tensor's data pointer is managed by the ET runtime. The kernels do not get a say on kind of allocating new.
So I would say that the way that is that tensors that are visible in the model, meaning like your graph with bunch of operators, they have tensors on them. Those tensor memory management of those tensors are handled separately compared to whatever you might do inside the operator. I mean, there are different ways to allocate and deallocate inside the operator implementation itself, but all the arguments of the operator, like out tensors and input tensors, those are managed separately.
Okay, but I guess my main point is that you guys actually are allowing full access to libc. In fact, it sounds like you're allowing full access to libstd C++ as well. Is that right?
So let's say a portable kernel, we don't allow any malloc or free, right? Now we pass in a allocator from outside that could be doing either pre-planned it, the scratch space, or it can be doing the malloc underneath the hood. But that is a decision that is passed from the runtime itself. The portable, if you look into the portable kernel implementation, it doesn't have any malloc.
For portable, that is true. And that is only because it's supposed to be truly portable to work on systems that don't have malloc or libc access, right? Custom operators can say that, okay, they don't target those surfaces and then are free to do what they want, similar to what delegates would do.
Okay, so I guess what I want to just understand is for the specific discussion we're having here about unifying ATen and Executorch kernel implementations, we are not in the portable world?
Yes, I don't think we should consider that as a portable space. These are custom operators. You should treat it as a custom operator, and then whatever limitations are for custom operators, that would apply here.
Okay, more questions. So custom op can access libc, can access libstd C++. Do I get any other libraries, or is that it?
I mean, you could do like another third-party libraries that you want to integrate with, like you can do BLAS, different implementations of BLAS, or like Slip.
I think Executorch doesn't have opinion on on what the custom ops can do. It all depends on like the deploy side of things. Like how do you want to deploy your runtime, or where do you want to deploy it?
But hang on. We are targeting mobile, right?
Yeah.
So like for example, if like concretely, I'm like, oh, I've got a great BLAS kernel that I want to run on CPU on Android? ? Stop me if I'm like going out of distribution. Like isn't it actually like non-trivial to do this?
Not sure I follow. So running some compiling some blast routine for deployment on Android surface? Is that you're saying that it's non-trivial to do via
I don't know.
Executorch
Is it?
stack?
Is it easy or is it not?
No, it is. I mean, we already do that. We have like beside portable operator library, a separate optimized operator library, and a bunch of stuff. Scott also had it. They can leverage other blast implementations as well, and we do that actually.
So the thing is, we already have custom kernels for Executorch that uses other third-party library like Blast, but then it's not easy to share the code with PyTorch. So that's the problem we are trying to solve.
Okay. Switching gears. Another question that I have is hang on. We're talking about threading, library access, memory allocation. Okay, let's talk about registration. So does Executorch use a static initializer based registration thing or something different?
Yeah. Same thing as PyTorch.
Okay, similar idea.
Mhm.
Is that?
But it doesn't have a.
Go ahead.
Sorry, go ahead. No, I was just highlighting that it doesn't have. It's not feature equivalent between the ATen dispatcher and dispatcher.
But I guess it's a requirement that you don't have to like explicitly list all the kernels somewhere to get them, in a place where you can get at them.
Yeah.
Okay. Any other questions from the room? Kamish, do you have more you wanted to present?
Yeah. So then we talked about three things, right? We can just copy paste. We can share just a kernel implementation and write a bunch of boilerplate code that are runtime specific, or the one that we are trying to really want to get feedback on is that implementation where we have a kernel and a single wrapper that is written with some common tensor interface that we sort of agree upon. There is a common subset, and then it has its own build code that builds differently depending on whether you go to building for PyTorch runtime or Executorch runtime. What this means is that we would build a few components for this. One would be to solve kernel interface issue. We'll build a stable to meet the C stable API requirement, maybe a C stable kernel interface with something like thin tensor or lean tensor. For operator registration, then we will have API similar to Torch library def and impl, but using this thin tensor definition, where it will take care of sort of code like generating the using meta programming code for registering the operator, where translation between ATen tensor to thin tensor and back and forth is taken care of when it's compiled for PyTorch runtime, whereas when it's compiled for Executorch runtime, it will do the same for going between tensor and this thin tensor definition. So that would solve the two issues around kernel interface and the operator registration. Then the issue around using this device or runtime specific APIs, like in the case of Metal, there are a bunch of features that we use. In case of CPU, thread pool is something similar. Could we refactor that in a way within ATen so that it's not strongly tied to the interfaces of ATen, but can be leveraged by this common kernel implementation? And then there's question of build and packaging. And the build and packaging is somewhat solved for on the PyTorch side because we do ship, like there are examples of library shipping custom operators are built on top of PyTorch interfaces, but on the case of Executorch, this is not quite there yet. So there are a few different options I listed, but we don't have like a actually strong way. These are some of the things I also want to get feedback on. Like current today, the way we do is like the Executorch specific artifacts are distributed by S3 for Android and iOS. We could distribute them via pip package, but this would not be like target hardware binaries. That would be like cross-platform effectively binaries that you distribute, but make it part of the pip package, or just do the source distribution via pip package perhaps, and then have the integration services compile it from the source. So yeah, so that's why I'm like the things I want to get a feedback from the room were around, hey, what do you guys think about the DevX for the previous two options, where is it so bad that we should actually solve for this compared to compared to these two options that we consider that is easily doable, whereas this one requires some investment. Second second thing I want to get feedback on was that, what are the other solutions possible that you guys think of, and should we consider the separating out the tensor interface and decouple that from the op registration, where maybe we can use thin tensor but continue to still use a separate op registration. Okay, so I'll stop here. Ed?
Yeah, I've got one more question, which is, let's say I'm in Executorch and I'm writing an op, and I want to call another operator. Is this something I can do, or no?
From where? From C++
From my
or
kernel. Like I'm just writing one of these custom.
No, yeah. So that's the one thing that we don't have, meaning that's something maybe I didn't highlight in this doc, is that if you want to write add mm, you could write just by calling mm and then add, but that's not something that's possible in Executorch. You could do it by, if you refactored some of the code in a way that that just becomes like a bunch of free functions that you can call from each other, but you don't have the redispatch possibility of, okay, you go to the kernel and then go back to the dispatcher to figure out where you should go. That's not there.
Yeah, basically, like if it was a library and you call the library, then that would work because you're allowing library access.
Yes, correct. That's right.
Okay, other questions, comments from the room? NYC.
I might just not have understood the answer to Ed's question before about the we use OMP for parallel on CPU and then don't use it for mobile. But if you're writing a kernel and you want to get the parallelization, how does that actually work when you want to share that kernel across in the way that's abstracted as you've described? Is the way to parallelize some abstracted API that is OMP on CPU and something else on non-CPU, or?
Yes, so I think there are a couple of possibilities, and one there is some examples on the work that's already being done in Torchio's experimental folder. One is you just rely, let's say, on pthread pool, which provides implementation for both Android platforms, but also for non-Android platform as well as x86. Or we have different implementation that you build differently, and then on some where OMP is available, you actually rely on that. So I think both are equally possible.
I'm actually not sure. Does anyone in the room know if inlining parallel 4 is important for CPU performance in ATen? Okay, too bad we don't have Christian here.
I can ping Scott.
You mean in Executorch or in?
No, I'm not on ATen.
Generally, inlining.
I assume I need to inline parallel 4. I'm not allowed to not inline it.
I haven't complained about it in 4 years. It doesn't mean it's not a problem, but.
Actually, I have a related question, which is I guess do you want to share binary or do you want to share source? Where sharing source means you would be willing to rebuild it for Executorch versus Python.
Yeah, it's not the binary, it's the source. Because you would have to rebuild for Executorch nonetheless, right? Because these are two registration mechanism is separate, so you will have to use it is a registration API to register to Executorch runtime.
Okay. Other questions, comments from the room? Yes, Tris.
I'm 80% sure that I think Executorch took the CPU flash attention kernel and made changes. Is that right?
Yes. Yep.
I guess, is the kernel as is? What happens when Executorch wants to make different decisions on the kernel source? I don't know if you guys have, for what it's worth, but.
That just ended up happening. I think we would have solved the same problem differently had it been that we were in this design space. So that's what happens in this other solution space, right? Where we actually copy paste stuff, and then we just try to refactor it into the way that works for the best, and then new use case come, and then we kind of keep using that because we are not really kernel sharing. But I believe we have solved the same problem different. Like the meaningful changes that were made to that kernel were to support group query attention, which you said that was added already. And then the other material change was done was like to support prefill versus sequence generation. Whereas HTTP has no notion of that really. HTTP doesn't understand whether you are doing decode versus prefill. But that was kind of encoded in that.
Any more questions, comments from the room? I'm gonna ask more questions. So,
Sure.
Another question that I have is, what's the scope of this? Like, how many kernels do you expect to like be affected by this?
So right now, this is really driven by the low-bit kernel work that we want to do in Torchio. So this would be mostly, so weight only and dynamic activation quantized, those one axis of choices, and then a few different bit weights like 2-bit, 3-bit, 4-bit, 5-bit, and like 4 or 5 of those. Those are the only ones that are off focus right now for like all these Llama use cases.
If I may jump in, there was a bunch of stuff that Executorch has copy pasted that is not a kernel at all, such as CPU bus,
Yes,
C10 scalar type, the ATen vec library. More generally, stuff in the Executorch portable type library will find things like ArrayRef, the half and bfloat 16 types. Those are just the things I have found so far and listed in the post. And then SDPA, which we talked about, or flash attention, which we just talked about, but that is a kernel.
Okay. Do we have reps from AO here? The question I want to ask is, what do the weight-only dynamic activation quantized kernels look like? With respect to sort of the like runtime questions I was asking about ET earlier.
Say more on that, Ed. Like, what do you mean? Like, how they look different? Like,
so I'm trying to get an understanding of like, let's say we do manage to share code, and there's this thin API and stuff. I want to know like how much change to the kernel needs to happen. So, okay, so first, I don't know who the right person on AO side to like ask this question to is. Mark, is it you? Is it Jerry?
I think Mark's on PTO today, but maybe I can help.
Okay, Christian, do you know what file it is? Can we like look at the file?
So your question is, what do the quantization
I just want to know what
kernels
the
look
kernel
like?
looks like. Like, we're proposing to make some API change.
Yeah.
So that,
yeah, I can. Let me try to pull something up. I can.
I mean, there's integer map mole kernels behind it that we generate with Inductor. There's cutlass kernels. There's various handwritten kernels in AO.
Ed, I just sent you a link to an example.
Okay. I don't know.
I can
who
also
wants
pull up
to,
something.
Yeah, can someone pull it up? I guess
Yeah.
Kamish, can you pull it up?
Yeah, I'm just gonna try and do that.
It's in your work chat.
Okay, I'm gonna share something, but it may not be super clear as in what's happening there, but I'm gonna share nonetheless. Let's see how we put this here. Yep. So this is one way that again I'm not super familiar with this code base, but this is one way this has been coded for CPU kernels. I don't know, maybe Digant is here, so Digant may have more familiarity on this. So if so you can say, so at the top you can say pass an activation, you pass an output. This is very this is M and K for the operator, group size for per channel. This is weight data, data book, maybe this for activation packing, and then activation pointer here, and then a bias. And this would get integrated in some way. We'll have some another wrapper that would actually figure out what are the rest of the parameters, where would they come from. But this one, these other data pointers and M and K and group sizes will come from in the operator definition.
Sorry, it wasn't clear to me. Is this already factored so ET can use it directly?
No, it's not.
Okay. So, okay. I don't know if you know this kernel well enough to say, but if you were doing the copy paste strategy, what would you have to change about this code?
So for that, I'm gonna have to find. Give me 1 second. If it has been integrated into as a Torch custom op, I need to find that. Let's see.
Hang on. So you just changed files. So are you saying that this header file, the waitImpl.h header file, can be used unchanged?
That one can be used unchanged. Then then when you integrate into, when you write the wrapper, that wrapper would be different. So that would follow the figure here. That we could do something.
Let's look at the wrapper code. Show me the wrapper code.
Let me find. Okay. And does this go back to rates? This should call linear. Okay, so this one calls a linear operator that we defined saw earlier, right? And this would be the somewhere this will be registered as an operator, but this will be its signature. The spec weights. N and K, I think, are passed in as a scalar tensor, as same as for group size, and then activations. Now you transfer tensor.
Okay, so just so to be super concrete, so you're like, wow, we need this kernel in Executorch. What you're telling me is that you would have to copy paste this linear CPU function, and I guess it's caller as well because it's templated. But you wouldn't have to copy paste the actual like algorithm on the inside.
Right. Yeah. So for example, here the output is like allocated somewhere. There'll be call to empty. Yeah, like here. Instead, in the ET, you would have an out tensor passed in, so you will just use that, and then all this other stuff will be refactored.
Do we actually have a satisfactory solution to depend on that header from the Executorch repo, though? Or would we have to copy paste it to be able to build with it?
So if you go with this solution here, then that, similar to Torch custom op, it would live in the same folder. So it would be here. You will not be doing this in Executorch repo. Okay.
Yeah, the SDPA one is a better example because it has the both wrappers. Or
okay, I can. Okay, so I can showcase another example. So just to set the stage for this is like the one that where flash attention kernel is copy pasted here, and then we create an operator on top of it. There is an Executorch operator for that, and then because we have to use this custom operator for ahead of time part, it has to be registered with ATen as well. So that is that component. Is that something that's interesting to say?
I do want you to show us the SDPA while you're finding that file. There's a question from NYC.
Yeah, sorry. Is malloc okay inside of an Executorch portable kernel?
Not in the portable kernel.
No.
Okay, because in the wait thing, there is a call to malloc in the kernel.
Yeah, so this is not part of the portable kernels.
Yeah, this is a custom op.
Sorry, is it? So it is allowed in a custom op.
Yes.
Yeah, earlier we established that the code sharing thing that Executorch needs is actually not the portable. So we're not talking about like truly portable kernels.
Okay, thanks.
Okay, so this is the STP op, and I'll go all the way to there. So this is the signature for it. So it has runtime context. These all tensors. These tensors are ET tensors, right? And then it's registered using this macro that registers the op. Now what we need to do is like have this op also available for ahead of time so that we can like do the export and whatever not and find this op. For that, STPA. Yeah, this one, right? So what this does, so for non-outward, it calls this op, right? This is how it's registered. There is an implementation of this. These are all ATen tensors, right? And it will then allocate the output tensor, and there's this call to wrap ATen, which what effectively does is that it has templatized wrapper for this function call, so that you can convert each of the arg from ATen tensor to E tensor, and then you eventually call this op, which is again a wrapper to the one that we saw earlier, which is this guy. So this.
So let me see if I understand correctly. So are you saying that this is how, like, is this basically a, what I call it? Is this like what I should expect to see if we do your second proposal, where we write things in a portable way and then wrap both ET and ATen around it?
Kind of is what you would see, kind of.
Okay, so I won't over-index on the particular details of this. I do have some questions. So one question I have is, so I liked that there was a header that I would just reuse between the two, and then sort of it was just the plumbing code that you had to copy paste. Why was that approach not doable for STPA?
So that would have, so if we were to do this, we would have to refactor effectively refactor out the code from the flash attention code specifically, right? So let's just focus on that. Factor this out from ATen, expose this somehow, right? So that we can actually include that header file. If we had that, then it would be possible, which would have meant that maybe this is shipped with the pip package, or I don't know, some other way to distribute that header file.
Okay, Dris, do you know how difficult or easy such a refactor would have been?
I don't think it would have been too difficult.
Because mostly you're just replacing the tensors with pointers, right? Raw pointers.
Yeah, I mean, like in my mind, essentially, I think in ATen right now, the calling code and the kernel code is in the same file. I think you just need to split those up. And typically the kernel code is just like raw C++ pointery types. So I think that's.
And what about the distribution? Meaning, like right now in Executorch, it's just like we pip install PyTorch. We don't have a third party. Like we don't have a. Is that right, Mango? We don't have like a PyTorch as a third party dependency. We just use a pip install PyTorch and then.
Right. So I think the reason why we are proposing a thin tensor is because we can, for Executorch, we cannot directly use the ATen tensor because of the binary size concerns. Yeah, if it's all raw pointer as the kernel interface, it's really hard to write a macro that, just convert the raw pointer into Executorch tensor. So we probably need a common ground, like the tensor.
But why do you need a macro? Just get the pointer and call the function.
So I think what this approach is like effectively like this, right? So you have a kernel that is just raw pointers, and then we'll write separate wrappers, and then you won't be able to do the sort of magic thing that that happens in wrap ATen.
Right. That also work. It's just a little bit more work.
Yeah. So I mean, I think that's my understanding of the question being asked here.
Yeah, I understand this response. NYC, do you have another question?
Yeah, so I just want to clarify. The flash attention, CPU flash attention in PyTorch uses PyTorch ops and then calls a kernel. How are we handling that on the Executorch side? Like, are you rewriting the PyTorch ops into the kernel?
Yeah, so really the core of what is really copied is like, these things which are like CPU flash attention, and the implementation of CPU flash attention has a bunch of stuff. So that's what's mostly copied. Not the operator that calls underlying routine is what is really copy pasted here, right? The rest is like not so much relevant.
Concretely, the CPU flash attention calls transpose, view, and expand. Is that in the kernel that you have
No, so
copied
that
over here?
those were removed. That's a fair point. So I left some comments here that we couldn't do this. Right?
Okay, so you're not doing this inside the kernel. Like you're calling like the view, transpose, etc. in Executorch elsewhere.
Yeah, or we actually, so this is written specifically in a way that it assumes the layout to be of this, so that you don't need, and operates on this layout. So all of that is like there is no transpose involved at all throughout it. Whereas in the case of ATen implementation, there is a transpose involved.
Richard, to answer it differently, they just removed it and just like they inlined the like
transition
into the kernel.
So going back to Drish's answer, like, is this, Chris, do you think like this is an easy transformation to do?
Well, so I think the first question is that initially they probably started the same. If you go back to that image, there's like a yellow and blue, and those are the wrapping code. And then there's the green kernel. I think correct me if I'm wrong, I think initially they took green and they wrote blue. But now since it lives in its own world, green has changed.
Right. So I had to do it in the first iteration as well, because there is actually no transpose. There is no redispatch to transpose that could work really here. So it's not hard to make work, because you can refactor like the portable or the library, so that it just becomes a function call and you call that.
Also, Executorch is not capable of doing a transpose without copying currently.
Yes, that's correct.
Which is the bigger problem.
Yes.
Sure. I guess my point is like just sharing a kernel is not as simple as just refactoring that PDA code. You also need to figure out like the ATen ops around it. Like, what to do with the ATen ops around it.
So do you mean that that code cannot it cannot dispatch to other ATen ops, for example, which are a lot of times the case for the operator implementation, that it dispatch to other operators. As a part of the refactor, you have to remove all such redispatch and make up for it.
Yes, as a part of refactor, you need to figure out how to actually handle the additional ops. Like in your case here, you have figured out how to do a transpose in line in a kernel.
I believe though that the way the CPU flash attention was written originally, I think that wouldn't have been too bad, because all the blast routines that were written underneath were all using various strides, and it was just passing the strides to the blast kernel calls. So even if we remove transpose, this specific instance could have been solvable, but more largely speaking, I agree. It's not as simple.
Sure. Yeah, I just wanted to point that out, because like we have other examples, like the torch version example, where like the code you can share is very small.
Yeah.
Okay, so zooming back a bit, let me think. So I guess we've spent some time talking about the copy and paste universe, which is actually not as simple as a copy and paste, right? So I'm gonna restate this proposal in the sort of way I understand it in its most robust form, which is that let's say there's a kernel that Executorch wants to reuse, and the kernel is currently written so that it calls all sorts of PyTorch APIs. Okay, so the straightforward thing to do that doesn't require any infrastructure investment is to refactor the kernel so that there is some, simple API that takes a lot of pointers and does the compute in a way that is independent of ATen. Because this is a very natural thing to do. People often structure their libraries these ways. Your boss calls are like this. And then manually write the ATen wrappers and the ET wrappers for it. And what I heard in the discussion earlier is that your main objection to this is that then you have to write a lot of boilerplate ET wrapper code in this situation.
Yep. And
are there other objections, or is that the main thing you're trying to solve?
I'm trying to think if there is a way to account for differences in times. So restricting this to only CPU only, I think.
Okay, I'll add one more based on the discussion. So another one is that the code that does the that has the simple interface has to be available in a way that you can build only it and not tons of other things. So in the case of AO, I guess it's header only, and that's why it was easy. Or I guess you haven't done it yet. But
we haven't quite. That's it.
So if it was an AO and it's header only, I guess I could believe that it's simple. Although maybe not, because maybe the AO headers are eventually including ATen headers, and you have to like factor this so that they're not including ATen headers. Right. And if you're doing a binary, okay, this is a question I forgot to ask. So in the non-portable world, you still have a binary size requirement, right?
Well, I mean, that's up to the, like, it's also a decision that product engineers or integration services can make, right? That, okay, these library ships, like, XML for example, is pretty large library because it has kernels, like similar to dispatch stub, right? It actually ships with, like, older ARM CPU architecture, newer ARM CPU architecture, it has kernels for all of those, and it will detect dynamically what CPU are on and figure out what kernel to use. So it ships with all of that. And it's the decision that you make whether you want to integrate or not. So that question is really around, like, who wants to pay for the cost?
So in principle, right, like we could just ship the entirety of ATen as a library, right?
Yes.
And you're telling me that there's some subset of users who would be indifferent to that cost?
Yes.
Really?
I mean,
the mobile apps would kick and scream. There's no way that's okay.
Like,
we have a requirement on binary size.
I understand, but like, that's a spectrum, right? It is a spectrum. In terms of, like, if you go to smart glasses, they will have say something else, but if you go to app, they'll say something else.
Yeah, and it's also kind of brutal because really we have to be the ones making the decision, not the product teams for most of them, because there's going to be like, I don't know, like 12 plus models, for each one. And so, and we have to kind of mandate per app, like, well, this is what you get.
Well, the short answer is size matters.
Yes, but what I'm saying is that for custom ops is not necessary. So we have we have selective build that works in some cases where the operators can be trimmed out, but the cases where, like, things like external pack cannot be trimmed out because of the reasons I mentioned. So then you have those choices available whether you want to ship and pay for the cost of it or not. If you have a custom operator, like I have a 3-bit kernel, it will give you great performance, but it has, like, 10x the cost of size, whether you want to pay for it or not.
But I guess I'm happy setting as a hard constraint based on some of the objections here that you can't use ATen. You can't even use ATen without all the operators, because that's also too big. And you can't be in a library where you don't have the ability to cut out operators you don't care about. Like, I think I feel like, because we're talking mobile, I feel pretty comfortable, like, just saying yes, there's a spectrum, but actually anything past these on the spectrum is a non-starter.
Yeah, I think we can say that. Yes, fair.
Yeah.
Okay.
Good.
So we talked about two things, right? So one is that it's a pain writing the ET wrappers, and two is, like, you've got to somehow extract the code in such a way that it has minimal dependencies so you can compile it by itself without pulling in the rest of ATen.
Yeah.
Okay. Actually, it's not clear to me, like, thin tensor doesn't really, like, save you at all on the second point. Like, the second problem is just sort of, like, actually, like, a huge problem that, like, nothing in this doc actually addresses.
No, so the refactoring is regardless. It doesn't really matter whether you are here in this diagram or the diagram below. You have to do that. The place where the thin tensor and friends would help is mainly around the wrapper being simplified, and you would have to write a
single. But I want to focus on this refactor thing because it's not obvious to me. Like okay, Driss, Executorch team comes to you and says, hey, we need CPU attention factored into a self-contained library that doesn't make any reference to ATen headers. And let's say let's do the, like, best version, which is they're willing to send the PR that does this. Do you take this PR?
It's only touching green.
So we looked at the SDPA code, and so there's some point when SDPA is taking all pointers, and that's the part that gets put into, like, some hermetic universe.
I mean, this one would have to take all pointers, right? And we'll have to refactor some of this. Like,
this is your
like
e-tensor version, so yeah, like it would either be like this or it would be raw pointers at this point.
Yeah.
Yeah, I think I would accept it. I think the only like caveat is they're probably, I mean, specifically around the like transpose changes, maybe they add templatization to like build their own version, like something that would increase binary size for ATen, but probably would accept it.
Okay, and let's Christian, I guess you're repping Torch.io. Will Torch.io refactor their stuff in this way?
Sorry, I'm not paying attention.
Okay, so concretely, and maybe anyone else from Torch.io can pipe up as well. The kernel we looked at, which is one tab to the left, right now it includes a bunch of AO headers, and I don't know if those end up. Well, there was another nicer header, which didn't have.
Yeah, I'll get to it.
Sure. So if that header,
that one should not use the.
Transitively includes ATen somehow, which I can't easily tell. Maybe it doesn't. There would be a refactor to make it not depend on that. And so basically there would be this like parallel universe of Torch.io headers, which are not allowed to have access to ATen. And it's just like all very raw. And like is the AO team willing to like set this up as a ongoing constraint in their repo?
I mean, it will only be relevant for some devices, right? Not for all of them.
Just CPU. Well, I don't know if in 6 months, Edge team is going to come back and be like, okay, we got to talk about CUDA now too. But let's say it's only CPU.
Is it something that we can lint or make a CI job so that contributors don't necessarily?
Sure, we can make CI jobs.
Like if it's automated and so on and so forth. Interesting. I mean,
yeah, and I haven't specified if you're taking in raw pointers or the thin tensor thing. It's just like this general concept without even having talked about the API.
I
have to think about this more.
So can I say something else? So I treat the refactoring of the existing. I'm sorry to jump the line. Refactoring of existing code as a separate thing compared to the things that, let's say, we are developing in Torch.io, which is being developed as in to write things in a way that, let's say, fits this picture. So then you're forced to be writing this in a way that is actually agnostic of really like header files and data types which are get tied to their specific runtimes. So I do want to kind of separate that out. Like the previous question, CPU flash attention, kind of seem fair, but we are trying to write new kernels. I think that's burden is on us to figure out like how do we do that.
Let's do some people. NYC Nostrand.
Yeah, sorry to zoom back into some details, but like, are exceptions okay in like the custom op for Executorch?
Yeah, so this was, so I was gonna, I didn't include it here. So the way this works in Executorch is that the core layer that actually is the interpreter has no exception. This doesn't support exception at all. So there's no try catch and anything like that. The only way to report errors is by the context, like there's a runtime context that I showed earlier, and if the kernel fails, you have to report the error through it. So that when the interpreter every loop, this is like typically how many of the C programs write, right? You just return errors or like whatever not. So that's why it returns, and then you would interpret that and abort at that point and whatnot. So code does not support that. So that said, like if we were to say like hey, custom operators would have exceptions. That gets a little bit trickier. If we can write report that will do try catch and then set appropriate error code for the interpreter, that would be one way to do it.
Is X an impact
throw? It will just abort.
Do the delegates throw, Kamish?
I don't think XML pack is the case, because that is also like, in the realm of just returning error codes, but I'll have to see like whether that's true for MPS or for MLL.
So nothing
Okay.
nothing blows up on ET's side if you start like returning exceptions from custom ops or whatever. It's I would say it's like a bit of a like a naughty child though.
This is a
But
binary
both,
size
right?
thing, right? Like people don't
Yeah,
like
but on
exceptions 'cause-
mobile,
Exception is-
if we're talking about for mobile, I mean they have exceptions today. Like this is I don't
Right.
think this is,
Right.
Okay, so I guess my point is like to answer like Ed's last question, like it might be helpful to just have a list of like what can be in a kernel and what can't be, because I did notice in the Torchio kernel there are also exceptions, so like that needs to not be in the green part. You can move on from it.
Again, as I was saying, like you could, if I wrote the wrapper where I did like try catch there and then just set the code appropriately so that it's you just don't like drive the interpreter crazy. That seems okay too. But I'll explicitly call that out. I did.
NYC Cholet, we're getting over, but I do want to like clear out all the comments.
Yeah, this is going back to your question of like, would Driss accept a PR, or like would Torchio be okay with like a parallel universe? It almost sounds like a different backend to me of like, oh, this is a backend that's like even lesser than the ATen backend where we use like raw things we can use within a kernel. And the question, like two questions I have are like, one, do we care? Are we trying to do it where ATen then calls into those like float star like operators or functions? Like, is performance going to be a concern there at all, or am I overthinking that? Or is it more like we're maintaining another copy of more raw kernels than our like composite explicit like backend key?
In the diagram we're
type
looking
of
at
line.
right now, ATen would call into it. I'm not too worried about performance because we have
Okay.
plenty of implementations that do just call into Floatstar APIs. So it's really more the
Okay.
management of the code base that is the minimal set.
Okay, so it's more like maintaining CPU backend, like, but refactoring our CPU backend to be
It's
even
like
more
making
minimal
another
than-
library like X as an NPAC or MKL or MKLDNN,
Yep.
which is
Right.
just free floating on its own.
Yep.
Driss?
Oh, I see.
Yeah, you essentially said what I was going to say. I feel like this green, yellow, blue thing exists today, and this is more of just a code structuring problem so that you ensure that there's no overlaps like there is in this picture. And I think that's doable, and maybe some guidance, like Richard said, and what's available would be great.
I'm getting kicked out. We are getting kicked out. If you guys are there, I'll try to join back in.
Well,
I'll join back.
I do wanna like set something. Okay, well, while Kanish is going away, so I think concretely what I want to suggest here is that they grapple with the like factoring things in a library thing without copy pasting, and like I would set as a goal SDPA and the Torchio kernels, and like I think I want to force them to write the wrappers by hand to start, right? And then if this is okay, then we can start talking about, okay, maybe there should be some wrapper interface or something. But like, I kind of want the split first. Christian?
I was just gonna suggest we for the SCPA, just to keep it concrete, like mention a specific device.
CPU flash attachment.
x86 ARM mobile.
ARM.
Like
They only mention ARM. They
ARM
didn't talk about
server side
x86 at all.
So this is ARM mobile
Yeah.
CPU.
ARM mobile CPU.
Okay. We have an SDPA kernel for that.
Yeah, we have a CPU flash attention kernel.
Okay, that's for x86 though.
Well, I mean, you can just compile it to ARM because it's not.
Okay.
You just
Is that good? Is that efficient or useful?
It's probably not that good, but it's probably okay.
I mean, given that it's usually like a bottleneck in LLMs, especially smaller ones, wouldn't an ARM optimized SDPA be more interesting as a standalone kernel and then not be really something that we want to share? Because we don't support server-side ARM. Or maybe we do.
Say that again, Christian.
I was just going to say, let's just include in this example the specific device you're targeting and why this kernel that we're sharing is good.
So we didn't really evaluate the merit of whether this is actually the best
Okay,
thing.
I want to quash this topic. NYC Nostran?
Yeah, another thing I wanted to ask was like if like Torch.io is okay with having Executorch specific build files inside Torch.io. So I guess that's a question for Christian. But like if we did the refactor, and then like in order to actually like check that it worked, like you would need CI in like Torch.io, and you would also need an Executorch to build in Torch.io.
No, that's fine. Because they're willing to rebuild for Executorch. So assuming you have a library that's self-contained, Executorch can just pull it in and then start building.
Right, but part of this proposal is that the build goes into Torch.io, and I'm being kicked out.
Okay. So here's my concrete proposal for you, Kamish, which is that there's a bunch of stuff we didn't get to talk about, which is like where the builds go, whether or not the thin tensor thing is a good idea. I think those questions are premature. I think what I want to see first is evidence that you can get the libraries you care about, Torch.io and SDPA, into this parallel universe land. And sort of, yes, it'll be annoying, but I think it's a constant amount of annoyingness to like write the wrapper by hand and do pointer structures and like sort of delay the thin tensor. You can always put thin tensor onto the pointer structures later if you want. Yeah. But my point is essentially write the wrappers by hand. I know it's annoying, but the first thing you need to do is get your downstream libraries on board with actually like carving out these parallel universes. And that is, I think, the first thing you need to solve.
Right. Okay, that's yeah. So that the stuff that is being done in Torch.io right now is following this, like that was, and so what you are saying is that let's just see this through, and see whether it's worth solving and going all the way down to the whatever this diagram is.
So concretely, I want there not to be two implementations of CPU flash attention for unless we get a good reason that's different than the reasons that were presented so far. And well, if you're saying Torch.io is already doing it, then there's nothing you need to do there. But I want validation that you guys are successfully being able to then build them.
Yeah, so that's not there yet. So that validation, like end to end, all of that running where we actually do, that's still work in progress. But it is following that principle right now.
Yeah. And what I heard from the room was essentially, it seems okay, but some stuff, like it actually is not a trivial thing, and it actually depends quite a bit on a kernel by kernel basis.
Okay, you mean like when you have to do refactor and stuff like that?
Yeah, the refactoring. Yeah. And the wrapper stuff like is not necessarily mechanical. Like sometimes there's like stuff you have to do.
Yeah, so from the refactoring, I think it's less concern for the new library that you are developing. It is a concern for the existing things.
Well, I mean,
I was just gonna say, I feel like it's when blue and yellow want different things from green. Which in the flash attention case, it sounds like there are some of those, and they're refactorable and they're doable. But I feel like with anything, if you get more cooks in the kitchen, there's going to be different ones. So
I think that I wouldn't over-index on that example also, mainly because again it just started its life as here, and hence it was like just started going in different directions. If it started its life here, then I think we would have solved it for different problems differently.
Okay, so do you feel unblocked for this?
I mean I feel unblocked as in like if room feels that okay, we should build this out and see it out for next whatever it's 2-3 months and see like few concrete examples before we can come back and complain that, oh, you know what, why did we not consider this? If that's the case, I think to me it seems okay, but there are also other folks on the design docs I want to see, like what Alban, Mungwei, I don't know if Mungwei is still around, and Richard think about it.
I think we lost all those folks. You should follow up with them offline.
Okay, I'll follow.
All right. Thanks, everyone.
Thank you.